Now that we understand the definition of second normal form, let's begin to examine its use in practice with some database tables. And if you are unfamiliar with the second normal form, please watch my previous video to understand what it means and how to apply it. As a reminder, a table is in second normal form if it is in first normal form, and no non-prime attribute is dependent on any proper subset of any candidate key of the table. And again, if you look at a table must have at least one composite candidate key consisting of 2 or more fields. If your table does not have a composite key, then it is automatically in second normal form. Let's take a look. So let's take a look at a table of invoice details that comes to us from the Murac textbook. Here we see invoice 1 for Connors Publishing. There are 3 details, 3 things ordered on that invoice: an Android ad, a MySQL ad, and a library directory. There's a second invoice for Zilka Design that includes catalogs and a MySQL flyer. And there's a third invoice for Zilka Design that has a card revision. So we need to analyze if this table is in second normal form or not. So my question is, we have to start off by identifying the candidate keys. Every time we look at second normal form, our first step is identifying the candidate keys. So what are they? It's obviously not the invoice ID, but it looks like it could be the invoice ID and the invoice sequence. But remember, when you're looking at candidate keys, you have to look at all possible candidate keys. And I think that the candidate keys include the invoice ID and the invoice sequence, as we mentioned. But there's a second candidate key, the invoice number and the invoice sequence. Notice that the invoice ID is probably an auto increment field, but the invoice number, that might have some business meaning. So there seems to be 2 ways to describe an invoice: by its ID or by its number. So the prime attributes would be attributes that were part of any candidate key. So we can start to eliminate some. So invoice ID is part of 2 of those candidate keys, and the invoice sequence is part of a candidate key, and the invoice number is part of a candidate key. So that just leaves us with the vendor name and the item description as the non-prime attributes. So is this table in second normal form? Well, we need to look at both of the non-prime attributes to determine that. Let's take a look at the item description. I need to look at any potential subsets of these candidate keys. So what are the possible subsets? Well, there's the invoice ID. So if I know the invoice ID, do I know the item description? Well, the answer is no, because here's invoice ID 1, and there's 3 different descriptions. So that's not dependent on the invoice ID. What about the invoice sequence? Can I say that the item description is dependent on the invoice sequence? Well, the invoice sequence, here's 1, and that's the Android ad, but here's another 1, and that's a catalog. So obviously the invoice sequence cannot determine the item description. So it looks to me like I need both the invoice ID and the invoice sequence to identify the item description. I could also use the invoice number in place of the invoice ID, but it's the same principle. If I have the invoice number and the invoice sequence, then that's what's going to determine the item description. So we're going to say that so far we are okay, because this non-prime attribute is not dependent on a subset of any of those candidate keys. All right, how about the other non-prime attribute? How about vendor name? Now here the story is a little different. It does look like the invoice ID determines the vendor. I mean, you really wouldn't have an invoice for two different vendors, and that's proven out by the data. There's invoice 1, and invoice 1 is always Connors Publishing, and invoice 2 is always Zilka Design, and invoice 3 is also only Zilka Design. So it appears to me like the vendor name as a non-prime attribute is dependent on a proper subset. In fact, it looks like the vendor name is dependent on the invoice ID. You could also make the argument that the vendor name is dependent on the invoice number. So given this, we would say that this table is not in second normal form. So how do we convert this table to second normal form? Well, the way we do it is we look at the offending attribute. This was the non-prime attribute called vendor name. This is the one that was dependent on the invoice ID. So we remove that from the table and instead put it in its own table associated with the invoice ID. And then the original table becomes one column smaller. To look at both these new tables, we want to see if they're in second normal form. So the candidate key for the first one is invoice ID. That's the only candidate key. And therefore, it is not composite and it cannot be subdivided. So this table is automatically in 2NF. This bottom table, our original table, now has missing one column, the vendor name. So we have to examine this again, and we'll find that this is also still in second normal form. The candidate keys are the invoice ID and the invoice sequence, and an alternative candidate key would be the invoice sequence with the invoice number. So the candidate keys have not changed. And therefore, the only non-prime attribute we're thinking about is item description. And item description is not determinable by a subset of either of those candidate keys. So we're going to say this is also in 2NF. Now, some of you may have noticed in the Murak text that their solution for a second normal form representation is different. I'm going to explain that, but clearly know that from the definition of second normal form, this is the least amount of changes you can do to put that table into second normal form. This is your book solution to move the table into second normal form. Notice that your book did move the vendor name into its own table. And the book also moved the invoice number into that table as well. And yes, this is a better structure. What we're talking about here is really Boyce-Codd normal form, not necessarily second. So the book moved it to second normal form, but they also moved it ahead of Boyce-Codd normal form, which we'll talk about later. The key difference is that the invoice number is part of a candidate key, and therefore it can remain in this table and still be in second normal form. Now, as we'll learn when we do Boyce-Codd normal form, both these tables are still in 2NF. So your book is not wrong, they're in 2NF. But this is an improved representation that has actually normalized this table further. We'll understand Boyce-Codd normal form in a few more videos. Boyce-Codd normal form is really a catch-up to find any dependencies that haven't been removed from a table, and it finds anything that we've missed from normal forms 1 through 3.